All right, so this warm-up is more or less kind of one question out of each of the sections that you did. Remember that the first topic we covered was ratios. Second topic was rates, so this talks about unit rates. And then the third one is working with proportions, right? Those are the three topics that we've looked at so far in this first chunk of stuff we've done. In the room here, there's 12 lights, and 10 of them are on. So if you're trying to write a ratio in each of these cases here, I guess I didn't need that much space, did I? Let's go back a bit. If you're trying to write lights on to lights off, you have 10 lights that are on, you have 2 lights that are off. And then the second thing, it says lights off to all the lights. Well, there's 2 lights off, but there's 12 lights in total. This first ratio, because it says in part C, explain what type that is. That is a part to part, because you're talking about part of the lights and then the other part of the lights, not all of them together, right? Whereas this one is a part to whole ratio, because you're saying it's 2 out of all 12, right? This 2 is part of this 12. Whereas in the first one, this and this are 2 separate parts. All right, you could also say that they're both 2-term ratios, and I didn't ask you to write any 3-term ratios here. That was a lot of the main concepts from that first topic, that first section we looked at. The second thing here, talking about unit rates, you could write a rate for this. To write it as a rate, first of all, before we write it as a unit rate, and this we might want to make some space. To write that as a rate, write it as a kind of a fraction, right? 4 goals in 2 minutes. This is a rate because it's a comparison of quantities that have different units. If you wanted to write it as a unit rate, just divide this, and then look at what units you have. 4 divided by 2 is obviously 2, but the units that you're going to have are going to be goals per minute, right? Because they come from that. So 2 goals per minute. If somebody scores 4 goals in 2 minutes, they're scoring 2 goals per minute. That's pretty fast in lots of sports, I would say. The second one, 200 miles using 10 gallons of fuel. Oh yeah, when I actually, you know what? Yeah, when I use this page extender, then they all turn to A's. That's a very good point. So this is supposed to be part B, but hopefully that's okay. 200 miles, 10 gallons. Okay, that's a rate. It's not a unit rate yet until you divide it. 200 divided by 10 gives you 20. What would the units be? Miles per gallon, because those are the 2 things you're dividing, right? Whatever 2 things you're dividing, that's what your units are. Right? You talk about miles per gallon or goals per minute. And then the last one, cookies and people. If you have 120 cookies, now I'm going to do it this way. Put the cookies on top and the people on the bottom of the fraction here. If you divide that doesn't divide nicely, does it? 120 divided by 25, you can either try and divide it in your head. It's going to be 4 point something. If you wanted to, though, you're welcome to resort to a calculator here. 120 divided by 25, 4.8. So that's not a whole number, but it's still something, right? 4.8, what would the units be? Cookies per person. Cookies per person. So that just means that if you have 120 cookies and 25 people, everybody gets 4.8 cookies. Probably you're not going to break a cookie up into 0.8 of a cookie and share it around that way, but on average, that's how much each person gets. All right? All the rates over here are called unit rates. All the rates on the other side are not unit rates, but they're still rates because they're comparisons. A unit rate is when the bottom term is 1. Keep in mind, for something like this, 20 miles per gallon is also the same as 20 miles per 1 gallon. right? 20 miles for 1 gallon. All right, last question here. I do want you to, and we'll have this everything turning into an A again here as soon as I do this. That's very interesting that happens. The computer is trying to think for us, and it's not doing a very good job of it. Okay, the last topic we looked at was using proportions, and we're not quite all the way through it yet, but that's the last one we tackled. Anytime you have an unknown, it's a good idea to use a variable. Okay, mathematicians are usually pretty boring. They always pick X, but you can pick whatever you want. Okay, so somebody's painting a room. So far he's painted, now look at the numbers that we have here, right? 20 meters squared, and it took 1.5 hours. How long is it going to take if that's the area? What's the unknown here? I'm going to highlight it in pink. How long, right? How long it'll take? So if you use a variable, the good thing to do to start with is not to just start using an X to say what it is. And the way mathematicians do that is they introduce the variable. They say, here's X. Let me introduce you to X. This is X. It's going to be something. But what they do is they say, let X be, or let X equal how long it's going to take. Number of hours. Something like that, right? You could say time to paint a whole room or something like that. If we talk about using a variable or introducing a variable or identifying a variable, this is what we mean. Okay, writing what's called a let statement, identifying it somehow like that, that's a good step to start with. And then writing a proportion. This was a big push for what we did when we first started looking at this. What you want to do is you want to compare, either you can put the area on top and the time on the bottom. Okay, so we're gonna write. We know that that you can do 20 square meters in 1.5 hours. This is a very large room, actually. 170 square meters is a very big area, so it's a large room. But we know that's going to be equal to. Where's the unknown here? Like, what's the other number? This is the two things I've highlighted in blue up there. But then, where does the green one go? Up here? Down here? How do you decide where it goes? Oh, it's 170 square meters. Look over here. I got area on the top, time on the bottom. It's got to be the same both times, so it's going to go over here, right? It's got to go up there. 170 meters squared. Sorry, maybe you were thinking I was asking where does the X go. The X goes down here, right? The X goes down there because that's the unknown, right? That's the time. The time is the thing that's unknown. So it's got to go area, time, area, time. That's a proportion. Okay, now I noticed that some of you are writing your proportion, but you're not writing an X in them. What you're doing is you're figuring out the answer and then you're writing it in your proportion. That's a true statement, but I'd like you to be able to do this, to start with the variable and then later on show how you're going to solve it, right? How you're going to solve it is, what we looked at is, we tried to figure out what the constant of proportionality, the proportionality constant was, right? And then use that here as well. If you know the two numbers, then you can figure out the constant, right? Proportionality constant. If you divide 170 by 20, what do you get? You get 8.5, right? Okay, this is times 8.5. I think it's a good idea to use these kind of curved arrows to show that's what you're doing, right? You could even write over here if you want. You could say proportionality constant is 170 divided by 20. You could do that if you wanted to. Now, if you want to think of something kind of higher level thinking thing to something to consider, that's up meters squared. That's meters squared. You know how I said up above here, your units, the units that you get in your rate come from the things you're dividing. Cookies and people gives you cookies per person. What about if these two things, then your proportionality constant have the same units? 170 meters squared, 20 meters squared. What would the units there be? Meters squared per meter squared? it's just a number. This is just a number with no units. The proportionality constant doesn't have any units because these are the same. It's like they can cancel out. Anyways, once you figure out that it's 8.5, then you can times the bottom by 8.5 as well, right? Times 8.5. So if you're solving the proportion and you're showing this, you might want to do this and say, here's my proportionality constant, and then I'm going to use that to figure it out, right? So x is 1.5 hours times, now I want to show you something here. In elementary school, how do you write a times sign? Or how do you write multiplying? It looks like an x. What's the problem with that in high school if we start using x's for variables? Yeah, you're going to get confused with this thing. Also, mathematicians are lazy. You know what they use instead when you start to get to high school math? Just a dot. They wanted to put as little as possible. They're really lazy, so they put a dot. Not a dot down at the bottom like a decimal point, but halfway up the line. Times 8.5 equals 12.75. What are the units on this? If you started with hours and you multiplied it by something, you're going to get hours. If you're doing a really nice proper job of this, the best thing to do would be to answer with kind of a little sentence or a statement. It'll take 12.75 hours or 12 3/4 hours or something like that. I am hoping we are okay with the different concepts in here. This is a little mini review of the 3 different things that we looked at in this section, this chapter, right? Okay, remember the 3 different concepts here, the 3 different things. Ratios, different types, rates, unit rates and non-unit rates, and proportions, okay? Proportion being when you're comparing this rate and this rate, or if you're comparing 2 ratios, that's a proportion. The big thing I think that we still need to work on is how to write a proportion with a variable in it, how to identify the variable in the first place, and then use it to solve the problem. I think for a lot of you right now, you get the concept of how to write a proportion, but you would just write the numbers. I'm thinking that for a lot of you, your solution to this would look like this. It would say 20 over 1.5 equals 170. You'd figure it out in your head. You'd say this is 8.5. And so this is 8.5. And you'd say 12.75. What's the difference between if this was somebody's solution and what I have up here, which is all this stuff is my solution? All of this stuff here. What's the problem with this? At the end, once you're done, like if I took, remember what I always tell you is if I took it to the teacher next door and I showed it to them, they have to understand, without having been here and heard this, how you got your solution. If my solution here starts with let x equal this, and then I write a proportion with a missing number, x, then I show how to find x. The problem is if you just write this, and then when you find your answer, you just chuck it back in the proportion, can I tell how you found that number? Not really. Sort of. Maybe something to do, like you could maybe decipher it, but it's not very easy to follow. And it's hard to even tell which was the missing number in the first place. I would like you to follow the steps that are followed here. Identify the variable somehow. Write a proportion with an unknown number in it, with a variable in it. Then afterwards show how you're finding the unknown. All right? Can we get going on wrapping up this last section on proportions? Your leaders are there to help. I'm here to help. Circulate around and help.